Hello everyone, my name is Lynn Kaminsky and I'm a professor from Sonoma State University in Northern California. I'm also the director of SSU's NASA-funded Education and Public Outreach Group. We've been given money by NASA to develop a middle and high school curriculum to help teach students how to build experiments that can be launched by high-powered rockets. This video is the first in a series that will demonstrate how exciting it is to build and launch your own experimental payloads. You'll be able to design your own experiments that will send you back data from the flight. Now, many of you may already have experience with model rockets. Model rocketry is a great hobby that can be enjoyed by students of all ages. And if you haven't already built at least one model rocket, I encourage you to try it out. However, the purpose of this NASA-funded project is to teach you how to design and build experiments that can be launched by bigger rockets, which are called high-powered rockets. So what's the difference between model rocketry and high-powered rocketry? Even if you haven't already built a model rocket, you may have seen model rocket kits for sale at your local hobby store. They come in many different sizes and popular brands like Estes and Quest. Here we have a model rocket that I built a few years ago. It's made out of a cardboard tube with balsa wood fins and a plastic nose cone. Other model rockets are made entirely out of plastic. It uses a solid propellant motor that is ignited electrically using a battery and an electronic launch controller. It has a parachute or streamers to help it land gently after its flight. This one has a streamer. The motors come in different sizes, which are denoted by the letters of the alphabet. Each subsequent letter has 2 times the total impulse, sort of like a measure of the instantaneous energy that can be delivered from the rocket motor. The smallest motor is called a quarter of an A, the letter A, and that has a total impulse of about 0.625 newton seconds. The next size is a half an A, which has a maximum total impulse of about 1.25 newton seconds. Then we have an A with up to about 2.5 newton seconds and so on. This is an A motor here. You can see it's not very large. The largest model rocket motor is a G, which can have up to 160 newton seconds of total impulse. Model rocket motors are not that expensive. These A motors cost about $2 each. Now here's another motor. It's a C, so it has 4 times the total energy as the A I showed you before. NASA co-sponsors a competition each year for model rocketry called the Team America Rocketry Challenge. This competition is run by the National Association of Rocketry, also called NAR. It's easy to get involved with NAR if your school wants to support a team of students to enter the competition. Now we're going to go launch this model rocket for you. It should go up a few hundred feet and should land pretty close to the launch pad. Since this has a C motor, we don't need more than a couple hundred feet in each direction of clearance to launch this rocket safely. And since it doesn't go very high, it should not drift very far, making it relatively easy to recover. In California, if you're older than 14, you can buy a quarter A through D motors through your local hobby store. However, to buy motors larger than that, you need to be 18 years of age.
Alright, today we're going to figure out how to launch an Estes rocket. We're going to need a rocket, a motor, in this case we're going to be using a B6-4, an electric match or an igniter, a little plug that goes in and holds the igniter in the rocket engine, and some wadding to protect the chute from when the rocket does its blowback to launch the chute out. So we're going to take the wadding, wad it up, and just stick it in the bottom of the rocket. We're going to roll up our streamer that will help slow down the descent of the rocket. Just put it in. Put everything together. And we're ready to launch the rocket. But first we need to put a motor in it. So I'm going to take the motor, slide it in. This particular rocket doesn't have any holding capability, so we're going to use just a little bit of tape. We're just going to tape around here, like so. the excess. I'm going to take our igniter, I'm going to bend it at 90 degrees and stick it in the bottom of the engine. We're going to take the little plug, making sure that we don't short out the two leads, and we're going to just stick it in here. That way it holds it in. Okay? Then what we're going to do is take the safety rod off, slide our rocket down, and then we're going to attach our two leads that are connected to our igniter. And then just attach a lead on either side, and we're ready to go.
Arming. Arm. And got light. And 3, 2, 1, go. 3, 2, 1, go. That went.
Okay, that was really fun. But if we want to do experiments using rockets, we'll need to be able to use bigger rockets that can carry experimental apparatus called a payload and launch the rockets to higher altitudes, so it will take longer for the rocket to descend to the ground. That way we can obtain more data. In order to do this, we will need to use high-powered rockets, not model rockets. High-powered rocketry is related to model rocketry, but everything is quite a lot bigger. And the smallest motors start with the letter H, which have a total impulse greater than 160 newton-seconds. In addition, in order to fly high-powered rockets, you have to be 18 and then be certified by either the National Association of Rocketry or the EEE Rocketry Association. Both of these organizations have clubs all across the USA. Here in Northern California, we have a NAR club called LUNAR, Livermore Unit of NAR, that operates low-powered launches at Moffett Field near San Jose and high-powered launches at Snow Ranch, which is east of Stockton, California. We also have the AeroPac Club, which is part of EEE. AeroPac runs launches exclusively at Black Rock, Nevada. Later in this broadcast, we're going to show you video that we've taken at Black Rock, but for now let's look at the parts of a high-powered rocket. If you want to fly a rocket with motor sizes H or I, you need a level 1 certification. But in order to get a level 1 certification, you first need to build and successfully fly a rocket using a level 1 motor at a club event where your sponsor is overseeing your certification flight. So here's my level 1 rocket that I built from scratch with guidance from Tony Alcacer, who's the president of AeroPac. It has a nose cone, a parachute, the parachute's actually wrapped in this non-flammable material called Nomex. So here's the parachute. And an airframe with fins. The airframe is made of 2 tubes, an outer tube which we covered with fiberglass and epoxy, and an inner tube which holds the motor assembly. We made the fins out of wood, and we covered them with fiberglass and epoxy too. The nose cone is made out of plastic, and it's filled with lead weights so that the rocket is balanced properly. We used a computer program called RockSim to simulate the design to make sure that it would fly in a stable manner and to see how high it would fly. Unlike model rockets where you can buy the motor cartridge, each time you do a high-powered launch, you need to put your motor together. You can buy reload kits for the motor and build it all to fit inside these aluminum tubes, which get reused each time. And the aluminum tubes come in different diameters to fit different size rockets. This rocket uses a 38mm motor tube, and I did my level 1 certification flight with an H motor. The motor included a delay grain, which waited about 10 seconds after the initial ignition to separate the nose cone from the body of the rocket, which then pulled out the parachute, and both pieces were tied together with these shock cords and I got them both back successfully with no damage, so I got my level 1 certification. I think it went up a couple thousand feet. In order to use bigger motors like J, K, or L, you need a level 2 certification. This includes passing a safety test and then successfully building and launching a rocket that uses one of these motors. So this bigger rocket is my level 2 rocket, and I built it from a kit. All the parts are made of carbon fiber, as you can see if I pull the nose cone off here. It's known as a minimum diameter rocket because it's so skinny. It only has one tube, and the motor tube slides right inside the airframe tube. Rather than using a delay grain, I decided to use an electronic altimeter to jettison the parachute right after apogee, which is the highest point of the rocket's flight. Now if I take this apart here, you can see part of the workings of the altimeter. The altimeter electronics are really inside this other tube. I used RockSim again to see how high it would fly with the J motor that had about 700 newton-seconds of total impulse and an average thrust of 350 newtons. The simulation predicted a maximum height of about 10,000 feet. That's 2 miles. The altimeter recorded how high it flew, and when I got the rocket back, the readout said it had gone up about 9,700 feet. Not bad. I got my level 2 certification in flight last year at Black Rock, Nevada, with help from Ken Biba, who is Aeropac's education director.